So where's the physics, you might be asking? Sure, it's fine to learn mathematics such that I can build a roller coaster that gets me somewhere in the minimum time, but why would I care about such a thing if I was in a physics class? Weirdly enough, it's not just people that design roller coasters that have some kind of interest in trying to minimize the time it takes to get somewhere, but actually light beams do as well. So you may recall that if you have a light beam coming into a medium, it will change its direction. And then if it changes media, it will change direction again. And you can use, because the speed of light equals the speed of light in vacuum divided by the refractive index. And so as you change the speed, you end up changing the direction. And we can motivate that when we derive Snell's law. But actually, there's another principle that you can use, which is Fermat's principle. And Fermat's principle is that the light is always trying to minimize the time it takes to get from one point to another. So the light, if it starts here, it will go to that point there by the path that takes the minimum time. So in fact, the calculus of variations you've already done, it has an immediate response. So rather than using Snell's law, if you have, say, a whole continuous distribution of different speeds, you could use a calculus of variations approach and use Fermat's principle. People often ask, why? How on earth can the light, when it's here, know how it's going to get to there in the least amount of time? Because it hasn't gone through that yet. When it's here, it hasn't yet experienced that there's a boundary there. How does it know that that thing isn't different, so it actually has to cross at different points to get to there? And the answer is actually kind of interesting. This is one of the cases where Fermat's principle is actually an emergent phenomenon from the actual wave solution. And indeed, all of the mechanics that we're going to come up with over the next few lectures is an emergent phenomenon that comes from the quantum mechanics. And so we'll actually learn that the principle of least action, this is what we've got here, is the principle of least time, but the more generalized one for mechanics is the principle of least action, which we'll learn about in the next lecture. And we'll learn that that is actually something that comes from quantum mechanics, and it's easier to understand how things know what's going to happen in the future, which they don't, but how that works when you actually come from it from a quantum mechanical point of view. Anyway, in the next lecture, so that's the end of this lecture. At the next lecture, we're going to do various examples, and we're also going to learn about the laws of mechanics and how this calculus of variations actually can be used as a very elegant and effective way to rework all of the classical mechanics that you've already learned.